Hi, welcome back to our Max class. How are you? I am fine here. Hope you are fine at your home. Last week we learned about squares, square numbers, square root, perfect square, and how to find the square root by using prime factorization method as well as division method. Now today we are going to learn some properties of square numbers. Okay, properties of square numbers. First you observe this number here, numbers and its squares. I have written here 1 square is 1, 2 square is 4, 3 square 9, 4 square is 16, 5 square is 25, 6 square is 36, 7 square is 49, 8 square is 64, 9 square is 81, 10 square is 100 and 11 square 121, 12 square is 144. Now see properties of square numbers. What is first property? First property says that the ending digit, that is the digit at its units place. Okay, ending digit means its unit place of the square number. Square of a number is 0, 1, 4, 5, 6 or 9. 0, 1, 4, 5, 6 and 9. Okay, these are the ending numbers. Okay, the ending digit, that is ones place of the square of a number is always 0, 1, 4, 5, 6 or 9. Let us check it. Okay, see, look here, 1 square, its square is ending with 1. 2 square, square is ending with 4. 3 square is 9, so ending with 9. 4 square 16, ending with 6. Okay, here 5 square is 25, again ending with 5. 6 square is 36, again ending with 6. 7 square is 49, ending with 9. Here 8 square, it is 64, ending with 4. Okay, and 9 square ending with 1. 10 square is 100, ending with 10 square 100, ending with 0. So always the units place is ending with 0, 1, then 4, 5, 6 and 9. Okay, always the numbers of a square is ending with these numbers, that is 0, 1, 4, 5, 6 and 9. Okay, these are the ending numbers, that is these are the units place of a square number. Okay, these are the units place of a square number. Which are the numbers? 0, 1, 4, 5, 6 or 9. Okay, these are the ending numbers, that is its units place. Ending digits means the digits at its units place of the square of a number. Okay, always 0, 1, 4, 5, 6 or 9. Okay, now second property says that a number having 2, 3, 7 or 8 at its units place is never a perfect square. A number having 2, 3, 7 or 8 at its units place is never a perfect square. See here, perfect square means the numbers ending with 0, 1, 4, 5, 6 or 9. Here 2 is not there, 3 is not there, 7 is not there and 8 is not there. So the numbers having 2, 3, 7 or 8. 2, 3, 7 or 8 at its units place is never a perfect square number. Okay, clear? The number ends with a 2, 3, 7 or 8 is never a perfect square. Always the perfect squares is ending with 0, 1, 4, 5, 6 or 9. Next property, third one. If a number has 1 or 9 at its units place, then the square of this number always has 1 and its units at its units place. That means a number 1 or 9 at its units place, then its square is also ending with a 1 only. Okay, for example, 1 square 1 and 9 square is 81. Its unit place is 1, you know. Same way, 11 square end with 1, you know. Its unit place is 1. And check it, what is its square? Its square is 121 is also end with the 1. Okay, and 29 square, its ones place is 9, you know. Ones place is 9. Its square is end with the 1 also. So always a number having 1 or 9 in its units place, its square is end with the 1 only. Because 9 square is 81, you know. So 1's place is 9. Its square end with the 1. If a number having 1 its units place, its square is also end with the 1. Okay, for both 1 and 9. 1 and 9. The number end with 1 and 9. Okay, its square is always end with 1 only. Its square is always end with 1 only. Okay, see here, 1 square 1 end with 1, you know, and 9 square 81 end with 1, you know. Then 11 square 121, it's also end with 1. If you want, you can check other examples also. Now property number 4. If the digits at the units place of a number is 4 or 6, then its square will always have 6 at its units place. Okay, if the digits at the units place of a number is 4 or 6, its square will always have 6 at its units place. Okay, always the square is end with 6. Example 4 and 6. Okay, 4 square is 16, end with 6. If it is 14 square is also 196, end with 6, you know. Now check it, 6. A number having 6 at its ones place, its square is end with 6 only. 6 square 36. Now you take 36. Its units place is 6, you know. It is also, the square is also end with 6. Okay, so the a number or a digit having 6 or 4 in its units place, its square is always end with 6. Okay, the numbers having 4 or 6 in its units place, then its square will always end with 6. Okay, clear? Let us check. Here 4 square is 16, you know, end with 6. And 6 here end with 36, end with 6, you know. Next, fifth property. If a number ends with n zeros, then its square ends with 2n zeros. That is, if a square ends with n zeros, then its square ends with 2n zeros. That means if the square ends with 1 0, its answer ends with 2 zeros. If the square ends with 2 zeros, its answer ends with 4 zeros. If a number ends with 3 zeros, its square ends with 6 zeros. That means just double. Take the double of a given number. Okay, take the double of a given zero. If a number ends with n zeros, then its square ends with 2n zeros. That is multiple of 2. So, or double. Okay, suppose a number ends with 1 0. Its square ends with 2 0. Double of 1 is 2, you know. And suppose a number ends with 2 0. Then its square ends with 2 2s are 4. Double of 2 is 4. 4 zeros. Suppose a number ends with 3 zeros. Its square ends with 6 zeros. See here, 10 square is 100. Here 2 0. Here 1 0. So here 2 zeros. Now 30 square. 30. In 30 only 1 0. Its square is 900. Here 2 zeros, you know. Same way 100 square. 100 having 2 zeros. And the square of 100 is 10,000. 4 zeros. 1, 2, 3, 4 zeros. Now 300. 2 zeros in 300. And its square is 90,000. How many zeros are there? 1, 2, 3, 4. In square, 4 zeros. Clear? Okay, if a number end with n zeros, then its square end with double zeros. Take the double of that n. Okay, that is 2n. 2n zeros. Next property, sixth one. A perfect square number leaves remainder 0 or 1 dividing it by 3. So any perfect square number, if we divide it by 3, the remainder is always 1 or 3. Okay, if you can take any perfect square number is divided by 3, you can get the remainder 0 or 1. Okay, let us check it. 9. 9 is a perfect square, you know. 9 divided by 3 is 3. What is the remainder? 0. Okay, now 16 divided by 3. What is 16 divided by 3? 5 3s are 15. 15 plus 1 is 16. So remainder is 1. And 25 divided by 3. What is 25 divided by 3? 8 3s are 24. 24 plus 1 is 25. So remainder is 1. So a perfect square number leaves remainder 0 or 1 on dividing it by 3. When a perfect square number is divided by 3, we will get the remainder 0 or 1. Okay. Any perfect square number on dividing by 3, we will get the remainder 0 or 1. Okay, clear? Next is seventh property. Property number 7. For any natural number n, we have n plus 1 the whole square minus n square is equal to n plus 1 plus n. This is a trick to find the squares very easily. Okay, squares or difference of squares very easily. That is, for any natural number n, n plus 1 the whole square minus n square, we will get n plus 1 plus n. N plus 1 plus n. This is very easy method. Suppose if let n equal to 8. So according to this formula, what is n plus 1 square? 8 plus 1 square. 8 plus 1 is what? 9. 8 plus 1 is 9 minus, here n is 8, you know, instead of n square it is 8 square is equal to, what is 9 square? 9 square is 81 minus 8 square is 64. Then find 81 minus 64. N plus 1 the whole square minus n square is 81 minus 64, 17. But we have the formula n plus 1 the whole square minus n square is n plus 1 plus n. What is n plus 1? 8 plus 1, 9. Plus n is 8. What is 9 plus 8? 17. You know, this is the easy method, you know. This one is easy. Second one is easy. 9 square minus 8 square means we want to find 9 square first. Square of 9 first. Then we want to find square of 8. Then we want to subtract. If it is a bigger number, it is very difficult. But the consecutive numbers addition is very simple, you know. 9 and 8 are consecutive numbers. Consecutive numbers means what? The number just after. That is continuous numbers. Okay. So n plus 1 the whole square minus n square, we can return n plus 1 plus n. Okay. N plus 1 the whole square minus n square, we can return as n plus 1 plus n. Clear? Next one, it's not a property. You just write down this. The sum of first n odd natural numbers is n square. Sum of first n odd natural numbers is equal to n square. Let us check it. N odd natural numbers is always n square. Here 1 plus 3. Here how many odd natural numbers are there? 2. So it is 2 square 4. Now here 1 plus 3 plus 5 plus 7. How many odd numbers? How many odd numbers? 1, 2, 3, 4. So it is 4 square equal to 16. But listen one thing, first n odd natural numbers, that means these are first n natural numbers. The order should be 1, 3, 5, 7, etc. If we are taking 157 etc. is not correct. 1357 consecutive odd numbers you take, continuous odd numbers. Okay. Next one, 1 plus 3 plus 5 plus 7 plus 9 plus etc. plus 19. Here how many numbers are there? 1, 2, 3, 4, 5. Then after 9, next one 11, 13, 15, 17, 19. Total 10 natural numbers are there. Odd numbers are there. 10 odd numbers. So answer is 10 square 100. Its sum is 100. So sum of first 10 odd natural numbers is equal to n square. Okay. Next heading, Pythagorean triplets. Pythagorean triplets means suppose any natural numbers p, q and r, if p square plus q square equal to r square, or p square plus r square is q square, or q square plus r square is equal to p square. The numbers p, q and r are known as Pythagorean triplets. So Pythagorean triplets means if take any two numbers and its sum of the square is expressed as another square number. Suppose if any sum of the squares of any two numbers, sum of the squares of any two number is another perfect square, another square, then it is called a Pythagorean triplets. Okay, sum of any two square numbers or sum of the squares of any two numbers is equal to other square number or other perfect square. Let us check the example. 3, 4, 5. Take it 3, 4, 5. What is 3 square plus 4 square? 3 square plus 4 square is 9 plus 3 square is 9. 4 square is 16. 9 plus 16 is 25. 25 means it is 5 square, you know. So we can say that 3 square plus 4 square is equal to 5 square. 3 square plus 4 square is equal to 5 square. Now check another example. Take 15 and 20. 15 square plus 20 square. What is 15 square? 225. Plus, what is 20 square? 20 square means 2 square is 4 and here 1 0. In 20 it is 1 0. So the answer is how many 0 in answer? 2 zeros. That is 400. So 225 plus 400 is 625. 625. Now the 625 is which number square? Yes, 25 square is 625. So we can write 15 square plus 20 square is 25 square. 15 square plus 20 square is 25 square. So 15, 20 and 25 are known as Pythagorean triplets. Same way here 3, 4 and 5 are known as Pythagorean triplet. Pythagorean triplet means if we add the square, sum of the squares of two numbers is the another square number. If the sum of squares of two numbers is another square, that is Pythagorean triplet. If p square plus q square is r square, it is Pythagorean triplet. Here 3 square plus 4 square is 5 square. 15 square plus 20 square, 25 square. Okay, now let us check another examples. Okay, try to find some more examples for Pythagorean triplets. Okay, now take exercise 3C. Question number 1. Seeing the value of the digit at unit place, state which of the following can be square of a number. First 3051. Here 1, you know, we already know which are the perfect squares. The numbers end with 0. Which are the perfect square? The numbers end with 0, 1, 4, 5, 6 or 9. Say perfect squares. Numbers end with 0, 1, 4, 5, 6 or 9 is perfect squares. So in this question, here first question, see, first question end with 1, so it's a perfect square. Second one, 2332 end with 2, you know. 2, if any number end with 2, 4 and 2378. A number end with 2378 is not a perfect square. So this is end with 2, so it is not a perfect square. Then next number end with 4. If a number end with 4, then it is perfect square, you know. Then 8. Numbers end with 2, 3, 8, 7 and 8. It's not a perfect square. So this is not a perfect square. Then last one end with 9. Number end with 0, 1, 4, 5, 6 or 9 is perfect square. So this given number is a perfect square number. Okay, look at your text and do. Next question. Squares of which of the following numbers will have 1 at their unit place? Here 57 is given, and which from these numbers which of them have 1 at which of them squares have 1 at units place? Here 57. We know that 7 square is 49. So this number is end with 9. 57 square is end with 9. So this is not correct. 81. 81. So 81. What is 1 square? 1 square is 1. So 81 square is also end with 1. So 81 square is end with 1. Now 139. What is 9 square? 9 square is 81. So 139 square is also end with 1. So this is correct. Now 73. 73. What is the units place is 3, you know. It's 73 means its unit place is 3. 3. So 3 square is 9. 3 square is 9. So this is not end with 1. 3 square 9, you know. So 70 squares, 73 square is equal to a number end with 9, not 1. Now 64. 4 4s are 16. 64's unit place is 4. 4 square is 16. So not end with 1. This 64 square is end with 6. So this is also not correct. So only 2 and 3 is end with 1. Okay. Next question. Which of the following numbers will not have 1 at their units place? 32 square. 32 square. You check it. Look at your textbook. Okay. 32 square is here 2. 1's place is 2. End with 2 square is 4. You know. So this is not end with 2. Sorry, 1. Our question is will not have end with. So this is not end with 1. Now 57 square. 7. Units place is 7. So it's also end with 7 square 49. 7 square 49. 7 square 49. So 57 square is end with 9. So this is not end with 1. Next question. 69 square. 69 square 1's place is 9. 9 square is 81. 81 by property. 81 means this is end with 1. The square is end with 1. Okay, end with 1. Our question is will not have end with 1. So this is not end with. This is end with 1. Now 321 square. Unit place is 1. So 1 square 1. So the answer, the square is also end with 1 square 1. Now 265. Unit place is 5. So 5 square 25. This is end with 5. This is end with 5. So this is also not end with 1. So 1, 2 and 5 are not end with 1. 3 and 4 is end with 1. Okay. We already learned the properties. The numbers, numbers in its unit place is 1 or 9. 1 or 9, then it end with 1. See this property. If a number has 1 or 9 at its unit place, then the square of this number always has 1 at its units place. Okay. So just thorough with this properties, then only you can do the problems. Fourth question, squares of which of the following numbers will not have 6 at unit place? 6. Here first question 35. We know that 5 square end with 30. 5 square is 25. So this is not end with 6. 23. Unit place is 3. 3 square is 9. 3 3s are 9. So in square also it is 9. So this is not end with 6. This is also not end with 6. 64. 4 square is 16. 4 square is 16. So 64 square is end with 6. Okay. Now 76. 6 square is 36. So this is also end with 6. Next 98. 8 8s are 64. End with 4. So this is not correct. Okay. Here we are using property number 4. If the digits at the unit place of a number is 4 or 0, then its square will always have 6 at its unit place. Okay. If the digits at the units place of a number is 4 or 6, then its square will always have 6 at its units place. So the number end with 4 and 6. Then its square is end with 6. So here only 2, 64 and 76. End with 4 and 6. Fifth question, do yourself the same method. The same method we follow in fourth question. Now sixth question, if a number end with 3 zeros, how many zeros will a square have? So a number end with 3 0, then its square have how many zeros? If a number end with n zeros, then its square have 2n zeros, 2 times. So here 3 2s are 6 zeros. Okay, a number end with 3 zeros, how many zeros will a square have? Square have 6 zeros. A number end with n zeros, then its square end with 2n zeros. Here 3, so 3 2s are 6 zeros in square. If the square of a number end with 10 zeros, how many zeros will a number have? In square it is 10 zeros. The number have only 5 zeros. Okay, number is 5, then its square is 5 2s are 10, you know. Here the square end with 10 zeros. How many zeros will the number have? Means 5 zeros. Okay. Next, 8th question. If it possible for the square of a number to end with 5 zeros, give reason. 8th question, 5 zeros. No, the square is never end with 5 zeros, because if a number end with n zeros, then square end with 2n zeros. 2n means it's a multiple of 2, you know. Multiple of 2 is always even numbers. Here 5 is an odd number, so it is not possible. Reason, 5 is an odd number. What is the reason? No, it is not possible. Reason, here 5 is an odd number. Okay. Always the square number have even number of zeros. Always the square number have even number of zeros, because our rule is if a number end with n zeros, then its square end with 2n zeros, you know. 2n zeros. 2n means multiple of 2. Multiple of 2 is always even number, you know. So this is not possible. 5 zeros is not possible. What is the reason? Because 5 is an odd number. Only the number of zeros is always even in a square number. Got it? Question number 9, 10 and 11 is homework for you. Next 12th question, second one. 12th question, second one. Give reason to evaluate 85 square minus 84 square. Evaluate 85 square minus 84 square. 85 square minus 84 square. We already learned one property. N plus 1 the whole square minus n square is n plus 1 plus n. N plus 1 plus n. So here n is 84, you know. N plus 1 is 85. plus 84. 85 plus 84 is 169. Okay. 85 plus 84 is 169. Same way 101 square minus 100 square. So n plus 1 square minus n square is n plus 1 plus n. N plus 1 plus n. N plus 1 square minus n square is n plus 1 plus n. That is 101. N plus 1 is 101. Next n is 100. So 101 plus 100 is 201. 201. Okay. Now 13th question. Without actual calculation, find 1 plus 3 plus 5 plus etc. plus 39 plus 41. We want to do without actual calculation. Okay. So only use the formula here. Here how many odd these are odd numbers, 1, 3, 5, 7, 9 etc. are, see, 1, 3, 5, 7, 9 etc. are odd numbers. We know that some of the odd numbers, n odd numbers, sum of n odd numbers is always n square. We already learned sum of n odd numbers is n square. Odd natural numbers is n square. So here 1, 3, 5, 7, 9 etc. up to 41 is there. So up to 49, how many odd numbers are there? 21. See, 1, 2, first you write 1, 2, 3, 5, 7 etc. up to 41. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 numbers. So here n is equal to 21. So sum of the n odd numbers, sum of n odd numbers is n square. That is 21. Here 21 natural numbers are there, odd numbers are there. So 21 square is 21 into 21, 441. So sum of 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus etc. plus 39 plus 41 is 441. This is the easy method, when you are adding these much 21 numbers are there. If you are adding these 21 numbers, it is very time taking process. So you just count how many odd numbers are there. So n, here 21 natural odd numbers are there. So sum of n odd natural number is n square. So 21 into 21, 441. Next, find 3 sets of Pythagorean triplets. Question number 40. 3 sets of Pythagorean triplets less than 30. Take 5, 12, 30. See, 5, 12, 13. These are Pythagorean triplets. 5, 12 and 13 are Pythagorean triplets because 5 square plus 12 square. What is 5 square? It is 25. And 12 square is 144. So what is 25 plus 144? It is 169. So 169 can be written as 13 square. So 5 square plus 12 square is 13 square. 5 square plus 12 square is 13 square. So 5, 12 and 13 are Pythagorean triplets. 5, 12 and 13 are Pythagorean triplets. Now you have to find 2 more examples, 2 more sets of Pythagorean triplets which is less than 30. Okay, check it. Now mark today's homeworks. Exercise 3C. 3C, question number 5, 9, 10, 11. 12th first question only. In 13, 1 and 3 only. 1 and 3. And 14, you have to find 2 more Pythagorean triplets. Already we found one Pythagorean triplet, Now you have to find 2 more sets of Pythagorean triplet. So these are the homeworks, and also you copy down these questions into a notebook. Whatever we discussed today, question number 1, 2, 3, 4, 6, 7, 8 etc. 12, 13, these questions you should copy into a notebook. Don't mark in your textbook. You should copy into a notebook. Okay. Thank you. Have a nice day.